Okay. Good morning, all of you. I hope you are doing good. Okay. So we have completed 5 units, 5th unit. Okay. Today in this session, we'll be learning about what is the content of the 4th unit. Okay. And how many parts we are having. And in that part, today we are going to cover about the first part. Why means in this first part, we'll be having about recursive and non-recursive functions. Okay, so this recursive and non-recursive functions we have already seen in the CTE lab about functions. Okay, so same topics will be there here. Okay, but here we'll be using different kind of techniques. Okay, and how we are going to write the algorithm and how that particular logic of that particular algorithm is going to be executed will be seen here. Okay, so coming to the syllabus. Okay, I have already shared today's content in your files. Okay, once all of you go through, open your files. Okay, open files. I have shared the content with today's date, unit 4 notes, like that part 1 notes, like that I have shared. So once all of you open that particular document and you can go through that one. So it will be very easy for you while I'm explaining. Okay, so when you are seeing the syllabus, did you all open that particular document, ma?
Yes, ma'am.
Yes, yes. So is it visible for you all, that particular document? Is it clear for you all? Yes?
Yes, ma'am.
Okay. So in unit 4, how many parts we are having, ma? In unit 4? In unit 4, how many parts we are having in a syllabus? First itself, I have shared the syllabus with unit 4, right? So in that, we are having 2 parts. Okay, the first part is defining about the problem solving heuristic techniques, and second one, problem solving designing techniques. Okay, 2 things we are seeing here in the unit 4. Okay, first one is heuristic techniques. Okay, and second one is designing techniques. Okay, so these are the 2 parts that you are going to cover here in this 4th unit. Okay, so the first part will be about the problem solving, okay, using heuristic techniques, and what are the different kind of techniques we are going to use in order to solve the problem. And coming to the second part, we are learning about designing techniques. Okay, so under heuristic techniques, we will be having 2 different concepts. Okay, 2 different techniques that we are going to use here in first part, that is nothing but recursive functions and non-recursive functions. That means we are using recursive technique and non-recursive technique in the first part. Okay, that is nothing but problem solving for heuristic techniques. Okay, coming to the second part, we are having is problem solving designing techniques. Okay, so under designing techniques, we are going to learn about 3 different kind of strategies. Okay, the first one we are going to learn about brute force algorithm. Okay, and second one we are going to learn about divide and conquer mechanism. Okay, and the third one we are going to learn about greedy strategies. Okay, where we will be making use of crucial algorithms. Okay, so these are the 3 different kind of concepts that we are going to cover here in the second part. Okay, the second part we will be going to discuss on Tuesday and Wednesday. Why means we are having continuously 2 hours class. So there we will be having some algorithms with some example explanations. We need to solve some problems. So at that particular point of view, we will be covering about brute force mechanism, okay, divide and conquer mechanism, and another one is greedy strategy. Okay, that 3 particular concepts are going to cover there in the 4th unit. Okay, so coming to the first part, okay, we are specifying that one as problem solving using heuristic techniques. Okay, so under heuristic techniques, okay, we need to solve that particular problem by making use of 2 different kind of mechanisms or 2 different kind of techniques. That is nothing but recursive and non-recursive techniques. Okay, so recursive technique is nothing but it is very similar to the recursive function. In CTE, we have learned about the functions, categories of functions, types of functions, all those things we have seen, right? So what is meant by a recursive function, ma? Recursive ante enti? Recursive function means anyone please unmute yourself and respond. Recursive function ante enti? A function which calls itself is nothing but it is a recursive function. I want you all to be responded, ma, because every time I am only explaining, but you are not giving any responses. How come I'll be knowing that that particular concepts are understand for you all? Okay, please respond whenever I'm asking any questions. Okay. There in the functions we have seen recursive functions. Okay. So recursive function is nothing but a function which calls itself is nothing but recursive function. Okay. Example in basic example adding of addition example I have given. Factorial example I have given. That means the same function is calling itself is nothing but it is a recursive function. Okay, so same thing, same concept we are going to use here in the recursive and non-recursive techniques. Okay, so under recursive techniques, we will be defining the definition of recursive technique is nothing but it is a procedure or a function or a subroutine. Okay, same thing we can specify. Okay, a function mean you can also specify that one as a subroutine. Okay, so recursive techniques will be applied in the functions only. Okay, whenever we are talking about the functions concept, then only we will be making use of this particular recursive mechanism. Okay, so in that particular function, okay, we will be specifying that recursive functions are nothing but they are the procedures or the functions or subroutines, okay, which are used for implementing in programming languages. Either you can make use of C, C++, Java, Python, or whatever it may be. Okay, so whenever we are writing any program based upon the functions, compulsory we will be making use of recursive functions. Why means this recursive function will reduce the length of the code and the time complexity will be more. Okay, so that's what instead of going for the non-recursive mechanism, okay, we will be going for the recursive mechanism. Why means this particular procedure is used for calling itself. Okay, so that's what we will be specifying. It is a procedure or a subroutine implemented in any programming languages whose implementation will be references to itself. Whose implementation will be references to itself. For example, if I am taking to find the factorial of from any given number, okay, so then I will be specifying that one as n factorial, f of n factorial, f of n I will be taking, okay, n factorial. For example, if I have given n is equals to some 3, okay, then what happens, I will be specifying 3 factorial, n factorial will be given as what? 3 factorial. Okay, 3 factorial will be written as what? 3 into 2 factorial. Okay, then again I will be writing this one as 3 into 2 into 1. Right? So this is the basic mechanism or the technique that I am going to use for finding the factorial of a given number. Okay, so that means I will be making use of this one in a for loop in non-recursive mechanism. That means I will be specifying for I equals to 1. You should not start with 0. Okay, everyone, if 0 into anything is nothing but what, ma? It is 0 only. So that's what we will be specifying n is equals to 1 or I is equals to 1. Okay, so for I equals to 1, I less than or equals to n, I plus plus. Okay, then after that we will be writing the code. Okay, for factorial. Okay, f of n is, we can specify that one as n is equals to what you can write, factorial of n is equals to, we can specify them as f is equals to n into I. Okay, this is the basic concept that we will be using. Okay, n is nothing but what? Okay, n I have given as 3. Okay, and initially I have assigned to 1. Okay, and finding the factorial, f is equals to n into I. Okay, n into I means what I will be getting, n is equals to what? 3. 3 into 1 I will be getting that one. I is equals to initialize to 1. Right? So 3 into 1 I will be getting 3. Now 3 will be stored here in f. Then it will be going to the incremental part. I will be 2. Okay, then it will be checking 2 is less than or equals to 3. Yes, satisfied. Then I will be coming here and it will be specifying n is equals to what? 3. Okay, so n is equals to what you will be getting, ma? 3. So 3 into I is, what is the value? 3 into I is 2. 3 to what I will be getting? 6. 6 will be stored here in F. Again, I value will be incremented. Now I will be what? 3, right? 3 is less than or equals to 3, yes, then it will be coming here and it will be executing this particular f value. So that then what I'll be getting, f is equals to n into I. N into I is nothing but what? 3 into n into I, 3 to what I'll be getting? 3 to 6. I will be incremented. 3 3 is 9, right? I should get only 6. Sorry, here I should take this one as f into I. Okay, initially I need to assign fact is equals to 1. Okay, whenever I'm initially assigning fact is equals to 1, then I'll be taking that one as 1 here. Okay, fact is equals to 1 into 1. Okay, 1 into 1, I'll be getting 1. Okay, then I value will be incremented. Okay, so when I value is incremented, I'll be getting 2. Then f is equals to what? 1. 1 into 2 will be getting 2. Okay, then I value will be incremented 3. Okay, then 3 is less than 3. Yes, f is equals to what? 2. So 2 into 3 will be what? 6. Okay, this is the basic logic that you are going to follow here for non-recursive mechanism. And the number of steps has been increased. Okay, so that's what we will be specifying this particular condition as non-recursive mechanism. So under non-recursive mechanism, we will be specifying that one as it is also a function or a procedure, okay, which will be implemented in any programming language, but it will not reference to itself. Are we calling any function here? Are we using any function in this particular logic, ma? No, just only what you are doing, just we are initializing the variables. We have taken f n is equals to 3, f is equals to 1, and then I values we have taken. But you have not used any function. We have used the loop and just simply we have written the logic, right? So that's what here what happens, the number of steps has been increased. The time complexity will be increased to execute that particular program. Why means that many number of iteration should be performed in that particular loop. Okay, so that's what here here it will be having low time complexity. Okay, so that's what here we are not using any function in non-recursive functions. Okay, non-recursive technique. Okay. Okay, in non-recursive technique, we are not calling any function. Okay, that function is not referencing to itself. Just we are calling the function and we are writing the logic and either printing that result there itself or we will be returning that particular result to the calling function. Okay, that's it we are using here in non-recursive mechanisms. Okay, so coming to the recursive mechanisms, what you need to do? You need to call the function itself. Okay, so in order to call that particular function, okay, what you need to do? You need to write the code for that particular logic. Okay, so in order to do that one, just what you will be specifying here means we will be calling, we will be declaring one particular function as factorial as, okay, f of int. Okay, then after declaration of the function, what you need to do? You need to call the function. So calling of function will be specified as fact of n. Okay, so after calling the function, what I need to do? I need to write the logic of the function. So in that particular logic of the function, what I am doing? I am going to make use of recursive technique. So under recursive technique, what I am specifying, it is implemented in any programming language is references to itself. That means this particular function should call that particular function again. Okay, then we will be specifying that particular function as a recursive function. So that's what the logic we will be writing is nothing but if n is equals to 0 or 1. Okay, then what happens? It will be returning that particular result as 1. Okay, if it is not, okay, then what you will be writing? Then we will be writing else we will be specifying factorial of n minus 1 into n. Okay, then we will be specifying that one as n minus 1 into n. This is the case we will be using. That means first I am specifying factorial of n. Factorial of n is nothing but, for example, if I have taken 3. So factorial of 3. Okay, then next one I am taking the second recursive statement as f of n minus 1. N minus 1 is nothing but what? 3 minus 1. That is f of 2. I need to calculate the function of f of 2. Okay. So then after that I need to specify what is the value I am getting. Okay. So now we'll see how we are going to execute that particular self-referential function. Okay. By making use of recursive mechanism. Okay. For example, if I want to find the factorial of 3. Okay. So in order to find the factorial of 3, okay, first I need to specify f of n is equals to 1. Okay. When f of n is equals to 1, when it will be when n is equals to 0 or 1. Okay. ఎప్పుడైతే n value అనేది 0 or 1 ఉందనుకోండి, the f of n, that means the factorial of n will be equals to 1. Okay. If not, okay na, ఒకవేళ f of n అనేది 0 కానీ 1 కానీ లేదు. Okay. n value is greater than 1. Okay. Where n value is greater, here we'll be writing here where n is equals to 0 or 1, factorial of n is equals to 1. Okay. Where n value is greater than 1. Okay. Where n value is greater than 1. Okay. Then we will be following that particular logic here as f of n is equals to n into factorial of n minus 1. Okay. This is the statement that you have to remember about this particular recursive function mechanism. Okay. So now we will see how this particular logic is executed. First, you need to declare your particular factorial function. Then you need to call that particular factorial function, and then you need to check that if n is equals to 1, return 1. Okay. Else, what you need to do? Factorial of n, else f of n is equals to n into factorial of n minus 1. So same thing I have written here. So how this one will be executed? Okay. So first I'll be making use of f of 3. Okay. So f of 3, I'll be specifying that one as f of 3 is equals to, what is n value I am getting here? 3, right? 3 into f of 3 minus 1. Okay. That is equals to, I'll be getting 3 into f of 2. That means same function it is calling. This is also f of 3 is one particular function and f of 2 is also one particular function. Okay, same function. What is the function? Factorial function. Okay, so factorial of 3 is equals to n into factorial of n minus 1. That means factorial of 3 is calling factorial of 2. So now what I need to do? I need to calculate the factorial of 2 value. So how I will be calculating? Then again it will be calling that particular function again. So I will be specifying factorial of 2 is equals to n into, again I will be getting that one as, now n is equals to what? 2. So that's what we will be writing, 2 into factorial of 2 minus 1. So factorial of 2 minus 1 is nothing but what, ma? Secondly,
factorial of 1.
It will be factorial of 1. Okay, that means function factorial of 2 is again calling the function factorial of 1. Okay, now I need to know what is mean by the factorial of 1. Okay, so factorial of 1 is nothing but what, ma? 1. By this particular first statement itself, we can specify where n is equals to 0 or 1. Factorial of 1 is equals to what? 1. So that's what directly I will be specifying here. Factorial of 1 is equals to 1. Okay, so now this is about the solving the logic of that particular factorial. That means it is calling that particular function there itself. Okay, so now we will be implementing that one by using this particular single statement. What is the recursive function statement I am using? Factorial of n is equals to n into factorial of n minus 1. Right? So therefore, okay, I have solved this one. Okay, therefore I will be specifying factorial of 3 here. Okay, I am going to find for what? N factorial. That means I am going to find for 3 factorial. So I will be specifying factorial of 3 is equals to, okay, so what is the statement? N is equals to, now what will it will be? 3, right? 3 into factorial of 3 minus 1. So I'll be getting 3 into f of 2. F of 2 value, I'll be getting that one as what? What is the f of 2 value? F of 2 is equals to 2 into f of 1 I have taken, okay. So f of 1, that is equals to 2 into 1, that is equals to what? 2, okay. So therefore I'll be specifying f of 2 is equals to 2 and f of 1 is equals to 1. So this f of 2 value I'll be substituting here. So I'll be getting 3 is equals to f of 2 is 2. So 3 2s is equals to what? 6. Okay. So that's what I'll be getting, f of 3 is equals to 6. Okay, directly you can substitute that one. If not, okay, now if you don't want to solve in a single statement, okay, so recursively I need to call this one. Okay, so at that particular point of view, what I'll be doing, ma? First, I'll be calculating only f of 2 only. Okay, so instead of directly specifying in a single statement, okay, first what I'll be doing, I'll be calculating f of 2. Okay, so I'll be taking f of 2 is equals to 2 into, okay, f of 2 minus 1. That is equals to what I'll be getting? 2 into f of 1. That means f of 2 is also calling the f of 1 function. Okay, so f of 1 function is called చేసినప్పుడు, okay, then what I'll be getting? F of 1 is equals to what? 1 value. F of 1 is equals to what I'm getting here? 1. So substitute that particular value here. So 2 into 1. That is equals to what I'll be getting? 2. So f of 2 is equals to what now? F of 2 is equals to 2. Okay, now substitute this particular f of 2 in this particular equation. Okay, you can take this equation as 1 and you can take this equation as 2. So then you can write substitute equation 2 in equation 1. Okay, then what you will be getting? F of 3 is equals to 3 into f of 2. So what is my f of 2 value? F of 2 is equals to 2, right? So that's what we will be specifying, 3 into 2. So finally you will be getting 6 value. That means f of 3. Therefore, f of 3 is equals to 6. Okay. Now f of 3 is one function. F of 3 minus 2, that is f of 2 is another function. That means same factorial function is calling itself again in the same function. Then it is said to be as a recursive function. Okay. So recursive is nothing but what? It is a function which is implemented in any programming languages. Either it can be C, C++, Java, .NET, C#, or Python, whatever it may be. Okay, it will be implemented in any programming languages which is referencing to itself. That means the function is calling itself. Then it is said to be as a recursive technique or recursive mechanism. Is it clear to everyone? Okay. And coming to the non-recursive mechanism. Okay. It is also a function or the procedure, okay, or subroutine which is implemented in any programming languages, but it is not calling itself. Okay. It does not references itself. Then that particular kind of technique or the mechanism will be specified as a non-recursive mechanism. Okay, there we are not calling any function. Just simply what you are doing, just we are calling the function. Okay, declaring the function, calling the function, and we are writing the logic of the logic of that particular factorial function in subprogram section. Okay, but just by specifying int f is equals to 1. Okay, then for I is equals to 1, I less than or equals to n, I plus plus. Then in the for loop, what you are doing, just specifying f is equals to f into I. Okay, so f into I will be specifying, or n into I also you can take. Okay, n is equals to, for example, if I have taken 5. So 5 into 1, then 5 into next what happens, 5 value, next value will be getting as 5 4, 3, 2, 1, right? So that's what I'll be getting. I value will be what? I value will be 1, 2, 3, 4, 5, right? So first factorial value I'll be taking in non-recursive as for I equals to 1, I less than n, I plus plus. Okay, in this I'll be specifying factorial. Okay, f I'll be taking f is equals to I'll be taking that one as f into I. Okay, f is equals to f into I. So the perform that particular logic. F is equals to initially I'll be taking that f value as 1. Okay, so f value will be initialized to 1. So 1 into 1. I value will be first value will be what? 1. 1 into 1 will be 1. 1 will be stored here in f. Again, I value will be incremented. So once I value is incremented, you will be getting 2. Okay, 2 into what is the f value? I got 1. Okay, 2 into 1 is nothing but what? 2. Okay, next I value will be incremented. 3. 3 to 6. So 6 will be stored here. Okay, and again I value will be incremented. I value will be 4. 6 4 24. Okay, so 24 will be stored here in f. Okay, and again I value will be incremented, then I value will be 5. Okay, 5 into 24, that is nothing but what? 120. So finally the factorial of 5 is nothing but 120. So just this particular simple logic we will be writing there in the subprogram section. Is it clear to everyone? So coming to the function, okay, whenever it is recursive function, then this is the logic you need to follow. That means you need to call that particular function. In the same way, 5 factorial తీసుకున్నాను అనుకోండి, then I will be representing this one as 5 factorial is equals to n into 4 factorial. Then again I need to calculate 4 factorial. F of 4 is equals to n into f of 3. Then again I need to find the f of 3 factorial. F of 3 is equals to n into f of 2. Okay, then again it will be performing f of 2 is equals to n into f of 1. So every time f of 1 value will be equals to 1 only. Okay, so that is the logic you have to keep in mind. Okay, so f of 0 or f of 1. Okay, when n value is equals to 0 or 1, then that particular value will be 1. Else you need to call that particular function itself. Okay, this is about the recursive and that is about the non-recursive mechanism. Okay, so here the time complexity will be more in this particular recursive function. But why means it should call itself multiple times, right? So that's what the time complexity will be high here in recursive function. But coming to the non-recursive technique, just we are writing that particular logic in a single function by making use of for loop. So that's what the time complexity, that is the execution of the time taken for non-recursive mechanisms will be less when compared to the recursive function. Okay, and in third step, you can specify that the code that you are going to write for recursive function will be very small. Why means in a single statement itself we can terminate that particular program. Okay, but coming to the non-recursive mechanism, the length of that particular code will be more. Okay, why means you are not calling any function. That particular code has to be written in n number of statements. So that's what the length of that particular code will be more. Okay, so these are the 3 different points that you have to keep in mind about this particular recursive and non-recursive mechanism. And one more point that you have to keep in mind about the recursive technique is that you need to identify that how many number of parameters that you are going to use in that particular function. Okay, the function parameters should be matched. Okay, the calling function lo మనం యూజ్ చేసిన parameters ఏమంటున్నాము? What you are specifying the parameters that you are using in calling function. Yes, ma'am. Calling functions lo మనము parameters ని యూజ్ చేస్తున్నాం కదా? Are we using parameters in calling function? Yes or no? Am I audible for you all?
Yes, ma'am.
Yes. So what are the parameters that you are using in calling functions are known as, whether they are actual parameters or formal parameters. Teja? Bharat?